Nonlinear systems of inequalities. In this example, we're going to graph systems of nonlinear inequalities. So step one is to focus your attention on the first graph. So the first graph here, y equals negative x squared. What do you notice about this graph? Well, what you should notice is that this is the parent function, a quadratic equation. A parabola. However, this is the parent. And we did something to this graph. What type of transformation was that? Yes, that is a reflection. A reflection about the x-axis. So this graph is going to be flipped, which means our parabola is going to be open downward. It'll be facing downward. Okay? So that's graph one. Now this is just a sketch there of the graph. And what type of line are we going to sketch? Well, we pay attention to our inequality symbol. Whenever you see a line underneath there, that indicates that you are going to sketch a solid line. So let me clear my screen for a moment, and we're going to go ahead and sketch the solid line of a parabola that's facing downward, the quadratic equation. All right, so there we have it. Next, we need to determine, are we going to shade upper or lower? And we are going to use that boundary method, because whenever you have an equation in that form where it's solved for y, you can use the boundary method. And that method states that when you have it solved for y, if you have greater than or equal to any of these two, you're going to shade the upper region. And if you have y is less than or y is less than or equal to, you're going to shade the lower region. So let's take a look at our inequality symbol for the first graph. Is that upper or lower? If you said lower, that is correct. So we're going to shade the lower region, and you may say, well, which region is lower? Well, anything up, above, and around, that is your upper region of this graph, which means that the opposite region underneath would be your lower region. So let's go ahead and shade below. And there you have it. We have graphed line 1. Now we are not done. We need to now focus our attention on the second graph. So let's take a look at the second graph, and it's also in the form where y is isolated, y is equal to, so we can use the boundary method again on that, but before we determine the shading, let's have an idea of what our graph is going to look like. So as you can see, it is still the parent function, the quadratic equation, and there's no negative out front, so it is not going to be facing downward. The parent function, this is the parent, it's going to be facing upward. However, we did something to the parent function. There's a -6 in the back of the function. What does that mean? What type of transformation is that? If you said a vertical shift downward, that's correct. So normally, again, the parabola would be here, but because it was shifted down 6 units, it would fall down and be here. Okay, and again, this is just a rough sketch of it, the parabola. Now, what type of line are we going to sketch? Is it solid? And actually, no, it is not solid. Notice there's no line underneath. So that is going to be a dashed line, which you actually need to leave some spaces in between your graph when you sketch that graph. Now, this is just a rough sketch of it. But you get the idea. So let me go ahead and erase my screen, and I'll draw a neater graph using the PowerPoint tool here. But again, yes, we are going to have a parabola. This was the parent function that was shifted vertically down 6 units. So here's our graph. And now we have to determine, are we going to shade upper region of this red parabola graph or below? So all we need to do is to look at our inequality symbol. Our inequality symbol has greater than, which indicates that we are going to be shading the upper region. So in terms of what is the upper region? Well, upper would be everything up above the parabola, and lower is the very opposite region, everything else. So because this is above, we are going to shade inside the red parabola. So let's go ahead and do that. Now, when you have systems of linear inequalities, your solution is not everything that you shaded. Your solution is just the overlapping part. In other words, you're looking for that region where you shaded it blue the first time, and then the second time around, on top of that, you shaded it red, the overlapping part. That's your solution. So if we were to erase everything else that's not the solution and just leave just the solution, it's going to look like so. So again, graphing systems of nonlinear inequalities, your solution is the region that overlaps.